Alright, sorry for today's delay. We are starting the stream. So, what to say? Last time we was getting a crash at the last moment of the execution of the program. But I have figured out what was going wrong. So, turns out when I made the initial implementation of branching in the CPU. Let's see, NES CPU and search branch. So I was doing negative mathematics wrongly, and that was causing an issue. So I was basically doing, I was making jump negative, and that was all, +1. But this is the right way to turn a negative, a number into negative for the CPU. So this is make the complement of the binary number, which is flips all the ones to zeros and all the zeros to ones, and then add 1. The reason why I am putting this mask in here is to get all the first 7 values and remove the 7th one, because that one is already taken care of with this negative symbol, because that bit should say this is a negative number, and that's why I am removing it and making it a signet in negative integer. So this is a negative 8-bit integer represented in a signet 64 bytes integer now. So now with this change, the game runs. Oops. And look at this. So the only problem is it doesn't always run. And that is because if I press up, the game crashes. And the reason, I had to find the reason of why this is crashing. So it says it doesn't know the opcode 233. If I look who 233 is, it says it is EA opcode, and turns out EA is not this one, this one. Wait a second, that doesn't sound right. What do you mean you don't have an EA? I registered it right here. Let's try once more, because it doesn't make sense. Oops. 233 decimal 233 is indeed E9. Oh, stupid, I was looking EA. It's E9, and E9 is subtract with carry. And the problem that we happened is that I accidentally did never implement it. So we was missing one operation. So this is the reason of why the CPU is not working right now. So we need to take care of implementing subtract with carry. And to do that, let's first create a task for it. Let's create implement subtract with carry. Oops. SVC instruction. I am not going to add unit tests this time, because I am tired of it and I already know this works. So I am confident enough to think I will do it correctly. And the other problem we have is that we have done a lot of changes and have not committed them. So let's see what are the changes that we have. Git diff part. So we added the observer. All of this is observer stuff. We added an await about to execute instruction. We injected that code into the CPU for making possible to inject the random number generation and inject the inputs. And I changed this call for a wait call so we can make a call wait if needed. I also added this virtual function about to execute instruction, and I made an override of this function for the snake game. So this was just a test that should not return. So let's start to fix what needs to be fixed. I don't want to return right away in the no-op, or in the, what was it? In the NES break. Where is it? Oh, it's on the NES CPU. I don't want to return, and I want to uncomment this is running equals false, because I was checking if this was the reason why the loop was stopping running, but it was not. The reason was the mistake on the jump instruction with negatives. This difference. So now we need to add changes to this slowly. So first of all, let's make the changes to the NES CPU. Git add part add-ons retro console emulator interface first and CPU, and let's see what we changed here. So we added the virtual function, that is correct. And now let's check the NES CPU. So here we added the call of this virtual function and made an override for the virtual function that for now is empty, and added the await to the call of the opcode. And we fixed the jump of the return value. So the reason, no, so this was a print I added to debug what was happening. So I don't want to include this, so I will put no. This is the fix for the jumping, for the branching, so I want to include this. I don't want this print. This was also for the debugging reason. Now I can revert those changes. So I will change add for checkout, and I will revert this change that I don't need anymore this print, and I will revert this other print. And I think this is all for this first commit to make it incremental. Let me see what is the diff in project Godot. So it seems we have added new inputs to the input map. and we have changed the main scene, and that is fine because we are not committing that yet, because to this point we don't have a test snake scene. So let's commit this. Git commit fix branch equals and branch no equal with negative offsets. Also make the execution of callback of yes, it's instructions async. Careful, you are on the main branch. Yes, I know I am on the main branch, and because I am the only developer in this, so I am just directly pushing to the main branch. So I don't have a development branch. I should trust myself. Git push origin main. If you want to see the source code, I don't know if it is on the description, but it is somewhere over here. Let's publicate it. So this is projects. I want repositories, GdScript emulator, and this one is public. So you can see the source code in here. Anyway, I did open this git status. So that was a fix, and I did not track it. The next change that I made a task to track was creating a memory observer. So I created a memory observer so I can get signals every time a memory is being read or write. Oh yes, right. I need to take a note for doing that before the next stream. Let's do that. Google Keep, and I will add a new node. Add GdScript GitHub to Streamlabs commands, and let's give it a background related to stream. Let's try anything, and done. So this is the task that I completed by making these two. These two is the memory observer. It is a class that extends ref counted and has a signal for memory read and for memory write, and it is emitted every time the memory is being written or written. And the flags tells you what operations is the observer interested in, so it will only emit the signals if the flag matches the interest of the user who creates it. So when it is created, it will have an instance of the memory that it is going to observe, from what range to what range it will observe, and what is the flags, which means what are the operations is it interested about. So if it reads, if there is a read of 8 bits, if there is a read of 16 bits, that is 2 bytes at a time, if there is a write of 2 bytes at a time. So this is the tool that I created, and it is a new file plus changes into the memory class. So the memory class is a friend class of the observer, and it has a create observer a function that will call the initializer that I just commented. We'll add it to the pool of observers and we'll return the new observer. So that's how we create an observer for the memory. So we should pass what is the range from and to we are interested in and the flags of the operations. Hey Earth, how are you? How are you? Are you on desktop? Are you on phone? Can you what? Can you see me? Can you hear me? How is it going today? So the observer comprehends the changes on memory and the changes on this new file, memory observer. So let's copy this, git add memory observer.gd and git add import, and let's add the changes of the memory. So I added a pool of observer, added a lot of help functions, so now we can see the size of the memory, get a subsection of the memory, we can create an observer, remove an observer, and this is an internal function with an underscore in front. And we are not adding anything of this file for now. So now we have completed the memory observer 2, which is this tag with number 46. Desktop today sounds good. Great to know. How are you doing? I was not paying that much attention last time you was streaming Rats vs Dragons. So I found interesting that you was seemed to be using some sort of visual programming by putting pixels on your picture like if they were commands to define what is the AI of the dragon, what was the animation that it was going to play, etc. So that was interesting, I have to say. Yeah, I was very surprised. So this is ready to roll. Git commit. Let's put a description to this. Create a memory observer tool class which emits a signal every time memory is read or written. Closes, it was 47, I think. No, 46. It was 46. Let's go. Git push. Haha, yeah. Photo hammer. That's a word thing Roland and I came up with for doing the layout. He turns the PNG files into label data. So I suppose that is what you refer when you talk of meta types. So I never understood why do you have like so much layer of conversion, because you make a JSON file that is later converted in another JSON file and then into a TS file or something like that. It was very weird. I don't know how it works. So yes, this is closed. Oh, and we actually fixed this. Snake main loop does not update graphics. So this is fixed now. So I can close it. So now we have this issue. We have to implement subtract with carry. So question is, For some reason that I don't understand, music sometimes stops. There we go. That's the noise conversion, I think. I don't know if it was a joke or you was referring to something I did not understand. So question, do I commit the snake test or I implement subtract with carry first? What do I have inside of this folder? Oh, I only copied the T. Shame on you. Git commit add snake game test for 6502 CPU. Git push origin main. So clean repository finally. Oh, I forgot to add project.godot. Do I want to add a mapping for WASD? I suppose yes. Let's amend the previous one and push it. I am hardcore. I push force. No, if you have an AI image, you need to analyze it. You tend to use noise algorithm. If I understood the work made Elstragon about converting different file formats. No, that is not what is happening in this case. So what is happening is that they are creating their own NES game. So the whole idea of making this emulator, or one of the ideas of making this emulator, is because they are making an NES game of his own. And once this emulator is done, they will be able to use it if they want to ship it. And that was one of the ideas, allowing people to ship games and also to include NES games as a sub game inside a bigger game, because it will be an add-on of that you can download. So what is this purple world? Let's see if I have an emulator. So this is from the Discord of Els. I think I don't have an emulator specifically for NES. We can try find out if RetroArch opens it. Are you launching? Okay, Steam is taking its time to launch it. Okay, so we have RetroArch, load core, Nintendo family. Let's search. Game Boy, NES, Famicom. The missing one would be the best. Let's load the content. Oh, I did not move this. So what is happening here? Sorry, I had to step away. all the extra steps we are talking are really just about workflow between the two of us. Yeah, so Els is the artist. He works with Photoshop and a couple more tools for making the images, because he has a very thought workflow, because he paints with the color palette in Photoshop, and then subdivides the screen on what tiles are using what color palette because of the limitations of the console, and then he has to convert those colored sprites into grayscale sprites to identify what pixel is what index in the color palette. And if you want more information of this, I invite you to come over to the Els stream on Thursdays and ask him about the NES color palettes, because he loves to tell about to explain about it. Isn't that right? I gotcha. Okay, so I was going to take this file that Els uploaded to his Discord and try it out. Okay. So now it should be on games, rooms, NES, and this one is the last one he uploaded, or Roland uploaded. So let's see how it runs. Okay, I think it crashed, but see that it is quite impressive. I pressed B. Let's try to reset. How do I okay, restart. Don't press A or B. Okay. I don't know to use this emulator, so sorry about that. And here is purple. So see, look at these animations. I love this part of staying at the bottom of the water and this sprite appears. It's so rad. And the controls confuses me because you are not supposed to control it with a normal controller. Glad you like it. Yes. So I don't really understand. All I know is that right now I can only kill red dragons because I have that hint in here. So I don't know if something will happen if I try to press A or B. So I will choose not. If I press select, it will change the color. It made the Mario sound. A and B aren't used at the game, so they are set as the book. Oh, I see. So the reason of the weird inputs is because this game uses Rob the Robot as the input device. And I don't know if you know it, but it's an awesome mascot from Nintendo. Was it like this? Else? This one, Rob. So it's an accessory created by Nintendo for the console NES. It was launched in 1984 in Japan, like the Famicom robot, and 1 year later it appeared in the USA with the name that is known as Rob. So this Rob has these weird peripherals in the sides, and it kinda seems to use it for as part of the input. See, it has a way to attach the controller and etc. So it has also these color buttons, so you use these color buttons instead of the buttons in the joystick. That is what I think I understand. So yeah, so else it was Nick, right? Nick and Roland are making their own awesome NES game, and it looks awesome. Let's see, I think I have to pause my music, and I can try to load the Hawaii scene. Oh no, that is just the Chrome. So these are the files that I was commenting before. This is files that else creates for Roland. This is the scene of the intro of the game. So that I have absolutely no reason to not show these awesome cutscenes and the game. It is just so incredible. And also this is what inspired me in first place to make this emulator, because I had that idea in mind for a lot of time, but this helped me to make that last push. Look, else it seems like the sun is like going a little high here. Maybe that's already fixed. This is so the music is probably wrong. I mean the level of music, because I did not make tests on the level of volume. So if you look at here, this is the level of volume that I am using for the desktop, and that is because my headphones are stupidly high, and despite on top of having that low volume, I have to lower the volume of my headphones. So I don't know if you can actually see hear properly the sounds of the desktop. I have to believe on the meters of the Streamlabs. So Smash Bros is really inclusive. Yes, they even have this black guy that nobody knows of. Like it is similar to those Spy versus Spy, but not quite. I never played that game. I just know it exists. Yeah, this scene is not supposed to list long enough for the sun to get that high, and also this is like a clipped version from a couple of weeks ago, maybe one entire month ago. So there has been some time where they could have made final touches. Plus, Roland sometimes makes some exports that starts at a specific level for testing purposes and etc. etc. So they don't have to always start from the start. Blah blah blah. Yeah, I don't think he's posted a new version with the next screens from the opening. So I did not download every single version. I usually just download the last one that we get. And in case you are curious about it, this is what is on those JSON files. So they have information of tile maps, right? So it's some kind of tile set. So it has information of the size of the tile and what are the coordinates and rotation and stuff like that. I don't know if this comes from Tilet, honestly. Um, and there are two versions. One is for 8 by 16 uh, 8 by 8 sprites, and the other is for 8 by 16 sprites. I don't really know how is the workflow, but they don't work with 8 by 8 sprites. They use 8 by 16 sprites. Anyway, we are getting carried away, but I love talking of this because I like a lot this project. Look at that pretty Jason boy. Yes, that is because it was not written manually, of course. Pa-pam. I think that's data from the NES ST screen too. There is sprite metadata, so it is how to build the sprite out of the CHR data. Yes, the CHR data, if I am not wrong, it is just the binary data of the sprites, just dumped into a file. It is a file like this. Give me a sec. This CHR, I don't know how to open it. I just know it is a tileset. So this is all I have downloaded, so we don't have anything else. But if I search on Discord, I should be able to find the president scene somewhere. We have Dragon Alert. Para pam pam para pam pam. Cutscene.net. I think this is the same one I have. Or it may not. What time is it? 21 April. And this one is 30 April. Yeah, mine is newer. So I think we don't have Mr. President as a NES file. That's sad. Room hacking utilities. Okay, I will bookmark this before I forget. GdNES. Thank you. Tell Max about everyone thinks that the president is using PR glasses from the 80s and 90s because he has colored glasses from the aviation or something like that. So everyone say that they are using VR glasses. I mean this one, sorry, 3D glasses, not VR. The glazes, not graces. This one with blue and red. So the sprite has blue and red crystals on the glasses, so everyone believes it is this kind of glasses, but it's some kind of different glasses that Nick knows about, and I don't. Anyway, so let's move on. They are American flag glasses. And is that a real thing? Because I saw I saw a sketch on the Discord about what they are, but I don't know if it comes from the imagination or it is a real thing. So I am not quite sure, but I find those details really nice. Like they give they enrich the world. That's what I mean. I didn't know it was a real thing. They are Americans. They don't need reasons. Well, Nick is American. I mean, Els is American. I think. Are you? Where are you from? It was Vermont. Are you from Vermont? Anyway, let's see if we can run Snake today before we end the end of the stream. So now that we know what is the mistake, we can implement subtract with carry as we was supposed to in first place. So it has immediate zero page absolute x, y, indirect x, y. So it has all the usuals and it goes after RTS. So the reason why I skipped is I picked out the ones that started with S and tagged them because I thought it was all for setting flags. So I picked it accidentally with this other tree. So that is why I got mistaken. I live in Seattle now, so well I need to eat something. Nice stream. See you guys. See you, Maxi. Oh, you changed your nickname, or maybe you switched your account. I didn't notice when that happened. Um, anyway, yes, I know that's your name, but you was using Android coders before. So let's see. Now the NES CPU is going to have a new fella. Let's do my usual setup, putting the code in one side and the documentation in the other. So after RTS, let's add between RTS and STA, let's add subtract with carry SBC. So we'll just duplicate a line and clear it. Let's make a new function, subtract with carry, and we are going to need how did I implement add with carry? Okay, add with carry to register. I included the register. Okay, to register. So I am going to pass what is the register. So I am going to use bin to remember what is the register, and I am going to pass my addressing mode, and I am going to create some duplicates of this line and start making variations of it. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 variations. All of them will operate on the A register, but they have different addressing mode. So we have immediate, zero page X. Let's delete all of this. Absolute, absolute X, absolute Y, indirect X, and indirect Y. So this is all the addressing modes, and now I will fit the opcodes. So let's start with OX, and first one is E9, second one is E5, Third one is F5. Next one ED. Next one FD. F9. E1 and F1. So we have all the variations. Each one has the right arguments. And now I want to fill the bytes and cycles table. So let's add bytes, 2 bytes, 2 bytes, 2 bytes, 3 bytes, 3 bytes, 3 bytes, 2 bytes, 2 bytes. And the cycles are 2, 3, 4, 4, 4, 4, 6, and 5. I am just ignoring this +1. That's a dark past. I kind of know. So now let's create a function subtract with carry. Func subtract with carry to register, and we are going to copy register and addressing mode arguments. And let's see how add with carry is implemented. Let's choose check add with carry. Let's copy this. So let's see, what are we doing? So we are getting the address using the addressing mode where the operation is going to be made. We are getting the value, and we are storing what was the previous value, which is needed to take the carry, the overflow bar, and the result is going to be value plus the negative of this value. So bar negative is going to be question minus the. So this keyboard does not let me use the add plus the command line to create the symbol, so I will have to use the character map. Here is the character map, and this is the symbol I want. Keyboards. So I want to I want the complement of the value, and I want to create a bit mask with this number 1, 2, 3, 4, 5, 6, 7, 8, and I want to also add 1, and this should be the negative value now. And now I will add negative, and the value is going to be result, and this is just a bit, it was a bit mask in case of overflow, and we update the overflow, we update the negative and 0 flags and the carry flag, blah blah blah. So I will just assume this works. The only thing we did was turning the second argument into a negative, bitwise negative. So let's see, can we now move up? So let's see, down, left. Can I move up? No! What did happen there? So I moved it up, but it did not work as intended. Okay, I captured an apple. Capture another one. So something is a little off, but it's already better than before, right? Oh, the inputs are so hard. There we go. So I am playing incredibly. So it's not perfect, but we are making progress. Okay, let's stop this. So now I want to see where are we messing up. Let's see, how did I do the jump? So this was the negative jump. So complement, uh, it's the same mask, and the only difference is it has an extra parenthesis. Seems to be the same apart from that. May that be parenthesis be breaking? No, it's not. So there is something else wrong in my logic. So we are going to need to find out that. So this instruction subtracts the contents of a memory location to the accumulator together with the node to the carry bit. If overflow occurs, the carry bit is clear. This enables multiple byte subtractions to be performed. So let's see. So we get the address, get the value, store the previous just in case, and we are making the value negative. Maybe this should not be set. Maybe I should not do this. Right. So maybe I have to first add the 1 to whatever the complement is, and then make the bit mask. And I don't even need to turn it into negative then. And I can just make a negative in here. And if result is less than 0, then we are going to turn it into negative. Result equals ABS of result or equals and we set the first bit to make it a negative. 1, 2, 3, 4, 5, 6, 7, 8. So this looks about the right size. So the thing is, we got a result was, if result is negative, we was setting a wrong value in here before. Okay, I did not like that. It's still working wrong. Making emulator in Godot seems super hard. So the thing is, usually when you make an emulator, you will use something like C or C++ or some kind of compiled or strong typed language. In fact, the tutorial I am following uses Rust, and Rust is much different. You already have signed and unsigned 8 bits, 16 bits, 32 bits, 64 bits integers. But Godot does not have them. It only has signed 64 bits integers. So I need to make the overflowing and the sign interpretation myself. So I am basically emulating this. I am literally emulating this 8-bit math using a 64-bit math container, which is the Godot integer. So I minimized something. It was over here. Okay. So I think I did something wrong, and to fix that, if I leave this as it was, then I can maybe check in here if the result was negative. So let's try if that now works. No, still wrong, still wrong. So question, is it ever negative? So it is negative indeed. So the result is minus 40. Negative. 40 negative is this number. 1, 1, 1. So it already has. It's already started with 1. And what is this? 1, 1, 1, 1, 0, 0, 1, 0. 0, 1, 1, 1, 0, 1, 0, 0. What was the number again? So this is again the same problem. I have to look at the binary number, but I only care of the first 8 bits, and this one has 64. Oh, it was a 10. So it's 0, 1, 1, 1, 0, 0, 1, 0. So that is a 72. And what if I set the first one to a 1? That is an F2 plus 40, F3. No, that. Right. I got a room, man. Good work, though. Fun to see you do the things. Thank you. Hope you have enjoyed it. It's about pizza o'clock, I think, but I suppose you don't eat pizza on Saturdays. So the negative is minus 96, and is that really correct? Value was 32. So let's try to look at this. The value was 32. And 32 is a positive number, right? So this is converted into negative. So I suppose what I need to do. Wait, let's see. Let's see the description on the tutorial, because there was a suggestion specifically on this. Oh, shit. I hate Windows tiling. After ADC is implemented, implementing SVC becomes trivial, as A minus B equals A plus minus B, and minus B equals the complement of B plus 1. So maybe I am looking too much into it, and I should not make any bit mask. And no negative. We should keep it positive, and we make it negative in... no, it's plus actually. And the result can be positive, and the negative result is just interpreted by these values. So this is probably correct. So let's see. Down, left, up. Nope. Still no. So at least the game is not crashing anymore. So let's see. Let's press up. Pa-pam. Let's start over. Press up, and now the value I have read from this address is probably the input. No, it should not be the input. So previous was 20. The value is 32. So I am trying to make 20 minus 32, and it is going to be a negative value. So let's see. 32 is this number, and we are going to make it negative. So we are going to flip it. 1 1 0 1 1 1 1 and plus 1, and it is going to become 70, which is... wait a second. Yeah, so I will have to make it absolute, I guess. And see what happens. I am confused. So advance, and negative equals to 34. That does not seem right. So I can also do this. Yes, this also sounds right. So I invert plus 1 and then make a bit clamp, so make sure it is only 8 bits. Oops. So what I am getting... Negative is 224. That looks more correct. 224 plus 32 equals 256. That looks more accurate to me. So now, what do we get? Oh shit! It's happening! It's happening! So one of the problems I have with the input is that I lost. Is that I need to keep the button hold in order for the snake to turn, and that is because I am setting and unsetting the value of the input when the button is released. So to make that work better, one thing I can do is go to my snake game and search for the input and do not clear on release. So it will just keep what was the last button pressed. And now I can move theoretically much better. Nice. So let's see. That was interesting. So we have a dead pixel in our screen. It is not updating this last pixel. So we need to fix that. Only pizza on Thursday? Sounds fair. I almost never eat pizza because I live eternally on diet. So let's stop playing this awesome game and let's fix the screen. So one of the issues is it is not clearing on start. So let's find the startup, ready, and refresh screen. Refresh screen is updating from 200 to 25 FF, and that seems about right, unless this slice is non-inclusive. Is slice non-inclusive? The absolute value begin and end will be clamped to the array, so the default value for end makes it slice the size of the array by default. It's a shorthand for slice array size, so yes, it is non-inclusive. So because it is size -1 is the last one. So yes, I have to indeed put a 600 in here. And secondly, put pixel get child this one seems correct. address minus 200. 0 is going to be 200 is the first one, not 201 or anything like that. So this part looks correct. I don't care about this observer anymore. I don't care of observing the head of the snake anymore. That has been debugged and fixed. I don't want to observe the apple anymore. So I only use the observer of the screen to refresh the screen. So the question is the observer of the screen look in the right range? So no, it is not reading all the span. Is it? Let me see, because from and to are inclusive in my code. Range 2, range 2. Okay. Okay, they are both inclusive. Range 2 is inclusive in my class. So yes, it was correct to use 5FF. So I simply don't quite understand what is going on, but let's see. If I make 5FF in hex, 5FF minus 200 is 3FF, which is 1023. So basically, the person who programmed this did not make room for the entire matrix on the screen. Apparently, they have eaten a pixel. I believe. So at least that makes sense to me. That is the easier explanation I find. And I honestly don't want to bother thinking if there is any other explanation. So we don't need anymore the apple or the snake observers. We only care of the screen observer. Yep. So it looks like this is the entire game code. Ba-bum-bum. This is just for reading purposes. It's to find what is stored at a certain memory location, and this is the ROM of the game. So I can find any constant, any read-only memory value easily. Like OC 90 plus 1 plus 2 plus 3 till the F. And yep. So I believe we are now done. And the only problem we have is that we have a dead pixel in the corner of the screen, but that is a bug in the game and device, not in our code. So I will accept that. So looks like I thought I saw a glitch in there, but I am also fine with that. Let's see if I can pick that corner. Yes. Okay, awesome. Let's record a video of this. I'm going to put this into the Discord later. And the snake is running and game over happens and it simply stops. So what I am going to do is instead of instead of refresh the screen, I could try to... Nah, I will just do this. Let's call this. And let's see. Refresh the screen and let's update the pixel. 124 with black. Okay, and that is the quick fix. So I don't know why that happened. We have a missing pixel. It is just strange. I am wondering now if maybe we have... Okay, I found it. This was the reason of all the glitches. We had an invisible pixel. Now we are basically... we have an extra pixel. So it has never been... the game has never been broken. Our screen was shifted. So that explains a lot. And we now don't need this anymore. So let's give it a try again. Let's try to move through the corner. Awesome. Okay, we'll make a new video. Now without that glitch. So cool. This is simply so cool. I'm so happy with this. So we can move on. Let's see. Git status. We have changed some stuff. Git add. And we created SVC. Created the function for SVC. And this will be part of a separate commit. Git commit implement SVC instruction. Oops, I forgot quotes. And closest. It was 47, I think, this time. Yes, 47. Git push origin main. Oops. So we are ready to move on. We are done with running our first game. This is complete, and the entire chapter 3 is complete. So it's time to move on to emulating the boss. So the boss has 1-bit control bus, 16-bit address bus, 8-bit data bus. So yeah, so it has forward and backward 8-bit read-write and 1-bit and 16-bit address bus. So yes, these are the registers and instructions. CPU gets access to memory, including memory mapped spaces, using 3 buses. Address bus carries the address of a required location. Control bus notifies if it is read or write access. Data bus carries the byte of data being read or written. A bus itself is not a device. It is a wiring between platform components. Therefore, we don't need to implement it as an independent module as Rust allows us to wire the components directly. However, it is a convenient abstraction where we can offload quite a bit of the responsibility to keep the CPU code cleaner. So read write pin, this pin, data bus pins, and address bus pins. So they are basically serial pins working all at the same time, I suppose. This is the RAM, I suppose. In our current code, the CPU has direct access to RAM space, and it is obviously to memory mapped regions. By introducing a BOS module, we can have a single place for infra-device communication, data reads writes, routing hardware interrupts to CPU, more on this later, handling memory mappings, coordinating PPU and CPU clock cycles, more on this later. The good news is that we don't need to write a full-blown emulation of data control and address buses because it is not a hardware chip. No logic expects any specific behavior from the bus, so we can just codify coordination and signal routing. For now, we can implement the bare bones of it: access to CPU RAM and mirroring. Mirroring is a side effect of the NES trying to keep things as cheap as possible. It can be seen as an address space being mapped to another address space. For instance, on a CPU memory map, RAM address space 0 to 800 is mirrored 3 times. 8 to 1000, 1000 to 18, 18 to 2000. This means there is no difference in accessing memory addresses 0 or 800 or 1000 or 180 for reads or writes. The reason for mirroring is the fact that CPU RAM has only 2 kilobytes of RAM space. Oh, so I was wondering about that. And only 11 bits is enough for addressing RAM space. Naturally, the NES motherboard had only 11 addressing tracks from CPU to RAM. Yes. So it was not using all 16 bits because it didn't need all of them for the 2 kilobyte RAM space. CPU, however, has 2000 addressing space reserved for RAM space, and that is 13 bits. As a result, the 2 highest bits have no effect when accessing RAM. Another way of saying this, when a CPU is requiring address at bit blah blah blah, the RAM chip will receive only blah 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 blah. So despite mirroring looking wasteful, it was a side effect of the wiring on a real hardware. It cost nothing. Oh, so now I understand what happened. So the reason why some consoles has shadow memory is not because it was some kind of buffer. It was because they are physically showing some wiring, and it was a side effect of that physical change. Emulators, on the other hand, have to do extra work to provide the same behavior. Long story short, the bus needs to zero out the highest 2 bits if it receives a request in the range of blah. Similarly, address space 2008 400 mirrors memory mapping for PPU registers. Those are the only 2 mirrorings the bus would be responsible for. Let's codify it right away, even though we don't have anything for the PPU yet. So let's introduce a new bus model that will have direct access to RAM. So why do we want a bus class? CPU virtual RAM, and it's an unsigned date of this size. The bus will also provide read-write access, implement mem for bus, so bus is a subclass of memory. PPU register mirrors, and so I kind of understand this. So yes, so basically what I want to do is create a subclass of memory for the NES. So I have created the NES CPU. And now I will create the NES memory. And it will inherit the memory interface. And it extends memory. So first, our function init will take no arguments, unlike the parent one, because the parent one was getting the size of the memory. So instead of that, we are passing a predefined size for the NES memory. So we are going to call super of the init function with the size of the CPU RAM memory. So const memory size equals, and what is it, 2048 2 megs, no, 2 KB. So, and we have a couple more constants. So we have RAM starts at 0. And the mirror ends at 1FF. So let's see. Let's try to understand what is this about. So after this number, it starts the 2000. So it is reading. If it is reading from the start of the RAM to the end of the mirror, it is going to get mirror down address. Oh, and it is cropping the address. Okay. So let's see how this works. Let's write memory read func, and let's copy the signature of all of this. So let's make some pass. This is annoying. This is not going to work as I expected. Anyway, so memory read, it's passing an address. If address bigger than equal to RAM, and address less than equal RAM mirrors end, it is just going to return mem read, I suppose. I mean the super. Elif. Address bigger or equal to PPU registers, and address less or equal to PPU register mirror ends. So mirror down. Oh yes, I have to crop to crop the memory size. I forgot about that. So let's try. This was var mirror down address, and it is cropping the value. And let's return memory mirror down address. What is wrong with you? Oh yes, this one is not returning anything yet. So for this case, mirror down address is going to use a different mask, and we're going to make push error. PPU is not supported yet. And return 0 for now, I suppose. Return 0. This was bar. Yes, underscore to avoid a warning. So the trouble with it okay, so we don't care of read and write. That is what we are saying, I suppose. Because read and write are just going to call the 8-bit version. Music, stop it again. Pa-pam. So for writing, we are going to have something very similar. So the part that we are missing in this code, so this is memory equals p-value. And this just returns. What is this else? Yeah, sure. Okay, this works. So now that we are doing this, we can take this memory observer and emit it here, and we emit it with the complete address, but using mirror down address for fetching. And that is right. And for the write version, can you stop barking? Right before or after setting the value? It's right before setting the value. We're passing old value is the mirror down address, and new value is the p value, and we use the full address. Okay. So question, what should size say? The full size is the same as before. What was it before? NES CPU was okay, this was the size. So let's make a constant virtual size let's return virtual size instead. Func real size. What is this? I am doing something wrong. Return memory.size. Okay. So I could also return this instead. Okay, PPU is not supported, blah blah blah. So the part that I am missing is the slice. So if begin bigger and equal to RAM and begin less or equal to RAM mirrors end, we can return this. Oh wait, so this is just begin. I also want the end. So wait a second. I think this is not what I should be doing. So I think what I should be doing is this. I'm doing something very wrong. If begin bigger equal RAM and begin less equal RAM mirror send, then begin is going to be changed. Elif begin is bigger or equal to PPU registers and begin is less or equals to PPU mirror send. Begin needs to use this other change. And we have to make the same for end. Right, this was begin, this was end. Okay. And what about size? Slice. Array size. Okay, so that -1 was wrong. Okay. Interestingly, yes. So this is the thing. The NES will have to use our new memory instead of this one. So the NES view on init is going to set memory to be a new NES memory. Oh, apparently I did a typo here. Okay. NES memory, and it does not take any argument. And the snake game it's going to create a new regular memory, otherwise it is going to crash. I can try it. If it doesn't crash, I would be surprised. So yep, I expected that. So yes, the NES, the Snake game needs to take a regular memory. Oh, hold up. Okay. So how do we know this is working? I have no idea. The last step is to replace direct access to RAM from CPU with access via bus. So it is using bus instead of memory. Implements memory for the CPU. So that sounds about right. Seems like the same as I have done, I think. Because this is exactly what I did. They just replaced memory for bus. And interestingly, they added these functions. Which is just a proxy. We don't need them, I suppose. Anyway. Git status. Git add. This fixed. This change. Oh, yikes. Yeah, I forgot to push before the changes to the NES game. Git reset. Git add p. Notice. This. Not this. And yes to this. Yes to this. Yes to this. Git commit. Fix the snake test game. Wait a second, I missed the message. Git status. Git add. Part. So we changed this in the memory. We have a new NES memory for the NES CPU. And we override it for the Snake game. And we have a new NES memory class. I forgot the argument. So I believe that will be all for today. It was quite a lot of progress, and believe it or not, that makes it all of the 4th chapter as well. So we are done with this extra 25%. So now we are done with the bus and we're ready to move to the cartridge loading. So thank you very much for watching and see you next time.